Okay, it's the overview, just so you can see what's going on. This is the drawing. Basically, input, voltage, battery, ZVS driver circuit to an induction coil to a Tesla bifilar, Schottky diodes, 50 volt DC cap into ultra-cap bank. One side's going through a switch into the input of the ZVS, the other side's going through to a DC-DC converter, which is keeping the voltage low enough for the inverter to keep running. If it goes over the 13 volts, then it cuts out, and then the capacitor bank just charges up. So then that's powering an incandescent bulb. So basically what it's going to show is I'm going to start the DC-DC converter to show what's in the capacitor bank, which will power the light. I will then start the battery to show you the system running, and it will show you the drain on the battery and the DC, or what's in the cap bank. Then I will flick the switch as the cap bank's power will then split, one side going back in, which will charge the run battery or stop the voltage from the run battery from coming out, and the other side will continue to keep this inverter running and start increasing its own charge, which is a little bit strange. It also shows from the amp meter that we have a lower amperage for the input for the system to drive, and on the output of the Tesla bifilar coil we have a larger amperage output. So I'll just try and show you this. So basically we'll start what's in the capacitor bank, and that shows we've got 13.8. Of course the inverter starts and the light comes on. I'll then start the run battery. The system will start running. This will show what's in the battery, which is going down. This is the run battery, because we haven't switched over yet. This is what's in the capacitor. So now I'll switch over, and we should see a slow increase very shortly. Firstly, we have the capacitor bank, which is charging up, and then we have the run battery, which is charging up. All the time we're still using the power. So I'll switch this off. And let the power drain down a little bit. The other thing I'll show is, I'll start the system again, so you can see the amperage input 0.10 and the amperage output 282. And again, just to show again the decrease, because the system's draining into the inverter, and as we loop the system again, I already see an increase in the capacitor. And a slow charge into the run battery. So until I have a system that's big enough to handle this, we'll just keep it as it is. To begin with, basically I had a run battery at 20.4 to charge the caps up to 14.40 from 8.9. Basically the run battery used 0.80 volts DC to charge from 8.90 to 14.40. So this was a minus of 0.80 volts and it gave a plus of 5.50. So we're about nearly 4 volts on the plus side when this system's running. And of course there's no battery in. And the system's just using what's in the capacitor. So a very large cap bank, a short input, a longer duration time, less voltage input for longer voltage output. You can see we've gone down because the inverter will only run at the 12 volts that's needed. So there you go, that's what I've got to show. Come back, John.